Hey there, boys and girls. Today we're going to take a look at fraction remainders, long division, where we express our remainders as fractions. Now, we've already looked at two other ways to express our remainders, and there's a grand total of 3 ways we can express them. So we can express our remainder using just the letter R. We just say what's left over. Now, as I've told you before, it's not my favorite method because it's the least precise, because we can get even further. We can become more accurate with our remainders because we can use decimals, which we've already worked on, as well as fractions. And that is what we're going to be taking a look at today. So let's review some of our vocab that deals with fractions. The top number of a fraction, we don't call it the top number. We have a very specific name for it. It's called the numerator. The bottom number of a fraction is called the denominator. Now, as a kid, I used to kind of get these mixed up, but I have a small little way that you can remember this. The D in denominator, I used to think about as downstairs. That used to help me remember that the denominator was the bottom number. So, when we're going to express our quotient as a fraction, the denominator, or the bottom number, is going to be your divisor. It's going to be the number you are dividing by. Okay, or the number you're dividing by. And your numerator, or the top number, your numerator, will be the remainder, or whatever was left over. So, this is really important right here. In general, when you're creating your remainder, as a fraction, your numerator will be the remainder. So whatever's left over is going to go over divisor, remainder over divisor, remainder over divisor, remainder over divisor. I like to repeat that to kind of get it ingrained in your brain. So let's draw a model of what's happening so you can better understand why we get fractions and what they represent. So let's go ahead and model 9 divided by 4. So I'm going to go ahead and draw 9 circles. 1, 2, 3, 4, 5, 6, 7, 8, and a 9th right there. And I'm going to divide it by 4, which means I'm going to go ahead and create groups of 4. I'm going to split it up into groups of 4. So I've got one equal group of 4, another equal group of 4, okay? Now let's take a look. We don't quite have a third one because we have only one. We don't have the other 3 pieces to say that we have those 3 equal groups of 4. So these are like, I'm just going to kind of create ghost pieces here. Had I have had 4, I would have had another group. I don't have another full group. I only have 1 out of the 4 that I need. So that is 1/4. So let's go ahead and take a look. So what this means, 9 divided by 4, is you have one group here, and 1/4 of a group here. So 1 plus 1 plus 1/4. So our grand total here, 4 goes into 9, 2 whole times, and then 1/4 of a time. So it's not that full extra time. It's 2 1/4, 2 and then a little bit more. Let's take a look at another example. So if we have 17 divided by 5, again, let's take a look at what's going on there. So let's create 17. I'm going to go ahead and do an array of, let's go by 5s to make our lives a little easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 2 extras. And let's create groups of 5 because I'm dividing by 5. So here's a group of 5, here's a group of 5, here's a group of 5. So I have 3 whole groups of 5. So I know my answer is going to be 3. 5 goes into 17, 3 whole times, 3 whole times. But then I take a look here, I don't have a full group of 5 because I'm missing 3. I would have needed 3 more. Had I have had 3 more, I would have had that group of 5. I don't have the full 5. I only have 2 out of the 5. So that's 2/5. So I have 2/5 of an extra group. So that is 5 2/5. So that's a visual model of what these fraction remainders are. It's saying that we do have one left over. Now, I'll go ahead and also write, this could have also been expressed as 2 remainder 1, because we did have one left over, but more specifically, it's 2 whole groups and a quarter of a group. And here we could have said that is the same thing as saying, hey, it went in 3 whole times with 2 left over, but we want it to be more specific. We don't want to just say that there was 2 left over. We want to say that we have 2/5 of an additional group. So it's 3 2/5. So let's go ahead and look at some more complicated problems without modeling, and let's just take a look at how we would tackle these. So I've got 485 divided by 5, or excuse me, 483 divided by 5. 483 divided by 5. I'm going to go ahead and start my largest place value. 5 does not go into 4. I'm going to use my 0 placeholder. But 5 does go into 48. 5 goes into 48 9 whole times. I multiply 5 times 9 is 45. I subtract. I get 3. I bring down the 3. 5 goes into 33 6 times. I subtract 30. Okay, so here's my remainder. Here's my remainder. Here's my divisor. Now remember, our fraction, oops, sorry about that. Our fraction remainder is going to be expressed as our remainder over divisor. So this will be 96 3/5, 3 over 5. So our final answer here would be 96 whole groups. So 5 goes into 483, 96 whole times, and then 3/5 of a time. So that would be our final answer, 96 3/5. Let's do another one together. 294 divided by 4. Okay, 4 does not go into 2. I'm going to put my 0 placeholder, keep everything lined up. 4 does go into 29. It goes in 7 times. I subtract 28, 1 left over, bring down the 4. 4 goes into 14, let's see, 3 times. I subtract 12. I have 2 left over. So if I was going to go decimal route, I would put a decimal and I'd bring a 0 down, but I'm not asking you to go decimal route. I'm asking you to go fraction route. You put the remainder over divisor, 2/4. So your final answer would be 73 2/4. Now, some of you might know that 2/4 is the same thing as a half. If you have 2 out of 4 things, you have half of it. So if you want to, oops, that's not a 2, sorry. So that's 73 1/2. Now with your mixed numbers, you want your whole number to be really big and you want your fraction to be the same size as your whole number. So your fraction, your numerator and denominator are going to be written smaller. And that's going to be your final answer. I'll accept both of these, 73 1/2 or 73 2/4.